So an insulated metal conductor is earthed before a negatively charged object is brought near to it. We've then got to explain why the free electrons of the conductor move as far away from the charged object as they can. And for part B, the conductor is then briefly earthed, the charged object is then removed from the vicinity of the conductor. You'll explain why the conductor is left with an overall positive charge. Okay, so let's look at this, and I would hope everybody's actually seen this happen as part of physics lessons. Now the way I would normally demonstrate this for you is I'd start off with what is a gold leaf electroscope. So that gold leaf electroscope is earthed, and in terms of the setup that I have then, because it's earthed, I've got positive and I've got no overall charge, so I'm just going to draw on positive and negative couples or pairs of charge. So overall you would agree this is neutral. Because it's been earthed, there's no residual charge actually on it. So what they then said, the next step they actually said was going to happen is a negatively charged object is moved near it. So what will happen then is I'm going to put a negatively charged object here close to it. So it's got lots of extra negative charge. So my gold leaf electroscope. Now the positive charges can't move. So positive charges are static, can't move. They're basically the protons. So I've got this set up. Now what will actually happen is the leaf on the electroscope will move out. So I've put the positive charges on. I'll explain why in just a second. So the electrons that were here are going to be repelled by the electrons that are on the negatively charged object. So these electrons are going to get pushed further and further away. So maybe that one gets pushed down, that one's pushed down here, these two are pushed down there. So you see all the electrons are basically getting pushed. So there should be a third one over here, one for each of those. So those electrons are being pushed away because they are repelled. So the negative charges, negative repelled by the negatively charged object. So electrons move away. The positive charges are attracted to the negative object, but those positive charges can't move. So on your gold leaf electroscope, what you end up with is a negative charge here and a negative charge here. Those two negative charges repel, which is why they lifts up. Exactly the same that happens when your hair stands on by a balloon or anything like that. So part B, we're going to look at, and what it says then is this is then temporarily earthed. So the scenario we're going to actually have happen then is we've still got our negatively charged rod in place. We've still got our electroscope. It's going to go like this. Now this time, the gold leaf is actually going to drop down, like that again. We've still got our positive charges. They haven't moved, can't move, they're stuck in place. But this time what will have happened is when I touch this, or when an object touches it, it's a hand, you can see here these negative charges are close together. They don't want to be close to each other. So what they actually do when this is earthed is those negative charges leave. Alright, so some of the negative charges actually come off of here. So you'd end up with a scenario again where you've got kind of something like that, where you've maybe lost a couple of the negative charges. This now is overall pretty much neutral. Sorry, actually no, this would still be out positive. Damn. So it would still be out positive because these negative charges would still be pushed down. So that's still going to be out at an angle. It might drop down ever so slightly, or it might drop down when you earth it because you've lost some of this repulsion because the negative charges have left. So what happens then, 3b, is you will now have a scenario where when this negative thing's removed, this negatively charged object's removed, this is going to come out of full way again. Your positive charges overall, they haven't moved, still exactly the same spots. But now you've lost some negative electrons. So overall, this thing now is going to be positively charged, because you've lost some of the electrons when it was earthed. So now maybe you end up with electrons like this. Then you can see overall these two are, if I draw it a little bit better, overall these two are positively charged, so they repel. This then is all, the whole thing is positively charged, so it repels, and on your electroscope you'll actually see that coming out to the side. Hopefully that was clear in terms of what's going on. Once again, hopefully you've actually seen that in class, so you've actually seen this whole process using a gold leaf electroscope. It's exactly the same process that is used to make hair stand on end, so with a balloon. So if you create static electricity on a balloon, exactly the same thing that causes this balloon to stick to a wall. So you should be familiar with all of these processes. Thank you.